So the next thing we have to do is actually place the pods onto the geometry. Now we've got some interesting challenges. We want to support the parts. The finger bit's going to come in and make the cut, but we've got all this fall off that would fall through onto the deck of the machine, so we have to actually support this entire piece with pods. Let's take a look at how we would do that. So we're going to come in here and we're just going to grab some pods and just simply support the part. Now, I have a total of 16 200 by 300, so I can't go hog wild with this. Now I'm not going to be machining the parts in this configuration. My intention is to actually cut the parts and pull them off the machine. In most cases, that's probably what you would wind up having to do. It's hypothetically possible that if I actually position the pods correctly, I could then come in and tool pad it, or I could remove all the junk, all the fall off, and then actually machine these parts in place. Since we're doing a 2 centimeter flat polish, I'm not going to bother with that. I'm just going to simply cut them out on the machine and have my boys polish them by hand. So I'm going to position a few more pods, just enough to support the parts. So that's enough to hold the parts up. Now I'm going to position a few pods strategically just to keep the remnants from falling onto the floor. I'm going to go ahead and use a small square pod down here to catch that remnant. So the idea is when I tool pad this, I'm actually going to bring the finger bit in from the perimeter and run it around so that it exit. If you were going to, and we'll go over a quick example of this. So now I've got my pods positioned. I'm going to delete all my junk pods that I'm not going to use for this batch. They're out of the picture. Now I'm going to do a zoom all. I can actually see what's going on. Now one of the things is we're going to process this as a closed geometry, so we want to make sure that the geometry actually is one piece, and it is. And in this case, it's one piece. So now what I want to do is assign tool directions. Well, we're going to process on the outside of the part, and I'm going to select the start point of where I want that to happen. So in this case, I want it to start right there. And in this case, I'm going to have it start right here. But I'm going to do something as a demonstration. I'm actually going to start it right here, and I'm going to show you what you would do if you were in a situation where you had to start the tool in the middle of the slab. So the next step is I'm going to go to Stone Vision, add finger bit pass, and I create a special finger bit. It's called Cut Finger, and it's designed just for this purpose. I'm going to select my geometry. Boom. Now, what you're looking at here is a start point and exit point, and I'm going to go ahead and assign a tool path to the other one. Add finger bit pass, cut finger, select geometry. Now notice that this one is starting on the outside of the slab, so the advantage is here I don't have to drill a hole or do anything to prepare that. That finger bit's going to clear the slab, it's going to go in and go around, and we can simulate that. Let me zoom in and show you how we're going to cut this apart. Now I'm going to hit and run a simulation. Here you see the finger bit going in, cutting the part, going in, cutting the part. Now you've completely cut the part, and you've actually, in effect, used your CNC as a saw. Now, in the event we were going to cut this way, if the finger bit came right down right here, it would crush the slab. So what we're going to do is we're going to take a circle. We're going to identify a 1 3/8 circle. And what I'm going to do is I'm going to take that circle and I'm going to put it at the start point, and I'm going to put one at the exit point. If I was going to run this program like that, I'd need to create a hole for that to go into and go out of. And then all I would simply do is go drill. We want to drill all the way through, select geometry, bling, bling. So now we've created a drill point, an entrance, and an exit. Now if I go to view operations, and this will probably be hard to see on the camera, because the sequence I did that in, I want to move this to the top because I want to drill my holes first. So now when we run our simulation, right here, I'm going to zoom in so you can see what's going on a little better. Now you'll notice when I run the sim, it drills the holes and the finger bit goes in, goes around, and then comes out the same hole and enters and does its thing. That's how you would do that on this. We're not going to do it that way, but that's how you would do it. I prefer to enter on the back of the slab. So I'm going to remove all my tool paths, and we're going to tool path this one more time. So I'm going to go Stone Vision, add finger bit pass, cut finger. I got to retool direction. Outside set start point. Okay, so I want to start right here, and I'm going to start right here. Okay, so we've got the pods in position. Now we're going to add our tool pass, add finger bit pass, cut finger batch, select geometry, We selected both our geometries. We now have the start points and exit points on the perimeter of the slab. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 pods in play. I have that many pods. This isn't a problem to set up. So the next step, we've written the program. It's ready to go. When I first talked to this customer about using the CNC as a saw, I thought it was kind of silly. Now I want to show you something interesting. We can do what's called a setup sheet. Okay, and I'm going to run a setup sheet, and it's going to tell us how long it should take to process this particular batch. Interestingly enough, it says 29 minutes. Now, this simulation is written with the tool running at about 18 inches a minute. We're probably realistically going to run at about 14, so this batch is going to take about 35 minutes to cut. As skeptical as I was about this concept, once I started running simulations, I got kind of intrigued and said, you know what, this actually makes sense in a different kind of way. It doesn't make sense for my shop. I have a saw jet and we blast out tons of kitchens, but for a small shop doing one kitchen a day, I think you can easily justify this. Let's do a proof of concept test. So once you've written your program, you're happy with it, on a Northwoods all you do is click on the barcode, and just like on the last video that we made with the saw jet, it produces a cut batch. And it comes out of my cool little printer. Remember this? We did this once before. It's a laser printer. It's faster than a dot matrix. Here's our program. We're going to go out to the machine and scan this in. And there's Mikey. That's my late night crew. I'm sorry, got that wrong. That's Mikey. That's Jake. We're going to go ahead and cut a slab on the CNC. Mikey's going to grab the barcode scanner and scan in with the barcode. Program comes up. Now you can actually see the pod placement that we drew. At the same time over here, you'll be able to see the laser projecting all the pod placement. Mikey and Jake are now going to place all the pods so that we can cut this slab. Watch these boys work. This is like a NASA pit crew, man. These guys know how to get it done. Now, what you're seeing them do, notice that we have a pod rack. We manage our pods very carefully. They're numbered 1 through 8 on left, 1 through 8 on right. And we make sure the pods aren't crossed. If you were trying to set these pods with pins, you'd go berserk. Notice how fast we already placed 4 pods. Here come the next 4. The key to making money with a CNC is minimizing spindle downtime. One of the ways you minimize spindle downtime is by having a machine that's ergonomically correct and easy to load, managing your pods and having a plan. If you look closely at the pods, you'll actually be able to see the grid that's being projected that they're lined up to. If you were trying to place these pods using the spindle, this would be about a 15 or 20 minute operation. As you can see here, it doesn't take all that long at all to position 16 pods. You're also going to have to throw in one small square pod right there. All the pods are now in position, with the exception of the square pod. Mikey's now opened up all the valves on the manifold. Notice that the manifolds are on the left or the right of the machine. They're very easy to get to, very easy to see, and they can get it done. That's the slab we're going to stick into our CNC machine upside down and process. This should be interesting. Now he's going to position the square auxiliary pod and plug it into the manifold. That probably took about 2 minutes to position all these pods. All the manifolds are open. Now we're going to go get the slab and put it on top of the machine. Now you can see the pod placement. The next thing you do is you bring your finger up and you hit 2 cm geometry. Now it's going to show the slab and the parts. And now the laser is projecting those parts. We're going to insert this slab onto the bed